Hello everyone. Now I'm going to show how to make an digit classification model using Torch and deep learning along with MNIST dataset. So what we do is first we make an AI model which runs on Torch, and we train the model using those MNIST dataset. With that dataset, we test the model using our own interface, wherein we can draw any digit, and it will predict the percentage of the digit, whether it's matches its learning or not. And then we it'll just tell the what digit it is. So first, what we have is we have this download.py. First, you should download the MNIST dataset using this using by running this command python download.py. So it'll start downloading the model, the dataset. So what we do is we start downloading the dataset um, in this dataset.mnist method. So we import the torch vision dataset and datasets and transforms, and we then download the dataset in a data row folder, which we have right here below the .vnv. Also, the vnv is virtual environment is optional. If you want, you can create the environment. So now you can see it's downloading. You can just ignore this error message. So it'll keep downloading. After it gets downloaded, it'll be moved into 10 folders under data. So it's not yet complete. So after this, it creates this MNIST underscore images. So there are 10 folders, each are labeled each of these from 0 to 9. So the main goal of this project is to make the AI model to analyze the digit from 0 to 9. So 0 is for 0, the images with 0, and 1 is for images with 1. So how we sort them? We sort them using the transforms. So it creates 10 folders in this for loop, and in all of these folders, we move the images based on the image using the transforms. And then now if we check, it's still extracting because it's a 60,000 images the data set is like 60,000 images, and it's sorting them out yet. It'll take some time though. If you have faster computers, like a GPU, it'll be more faster. So in model.py, we import random. So this will randomly create a seed, and then we'll load the data set from the data folder, and then we'll train the model using the data folder. For testing, we don't train the model, we just test the model. So then we find the shape of the image and the labels shape. So here what we do in x underscore train, we find the size of the training data and then the testing data also. And then this is the important part of the code. This creates the entire model. So how this model works is using a neural network which is sequential. That means the neural network is located next to each other. So in the first layer it will be the input layer. So first layer will be having 256, will totally be having 256 layers, and 28 into 28 is the size of the image, and it will be a ReLU. And next there is a dropout value also. And then this is the first layer. So this is the input layer having 256, and then this is 128. So there'll be 128 neurons, and again there is another ReLU, a dropout value also. And then this is the hidden layer. So the second nn dot, the third nn dot linear in this nn dot sequential is hidden layer having 128 neurons. So the weights and all will be added onto this hidden layer. And then there is the linear. So this last one is the output layer having 10 neurons, 128, 64 and 10 neurons. And then we will compile the module into a file. So there'll be a .pth file. There we will store the file. So it will be somewhere, yeah. So here we'll be saving the model in this file so that we can run it on our interface. So there'll be 20 epochs. So in the 20 epochs we will train the model based on what loss and accuracy it gets. So it at initial, so the loss will be very low, it will be less than 1, but the value will be nearly equal to 1. The accuracy value will be equal to 1, so it will be more faster in training. It doesn't take much time. So if you want, you can change the epoch value. If you want, you can put it to 10, or you can change it to more values like 30, so that it will be more accurate, but 20 is more ideal. And then we loop through the epochs, and we train the model. We increment or decrement the loss value by based on the image it's being trained on. And then we save the model. After saving the model, um, we go here and test the model by giving it as a digit 7 value. So yeah, this is how the model will be created. So now the data set is completely sorted and downloaded. Now we will run the model.py. So we type python model.py. So also this code will be uploaded to GitHub for further referencing. So first we train the model in this, so you can see how it is. This is the model. So what it does, it printed the entire thing down here, and this is the image shape and the label shape. There's 60,000 images, each of them 28 by 28 pixels, and the labels also are 60,000. So each image is labeled. So it says supervised learning. For the testing we will be using 10,000 images. So it's so what it is, totally it is a 10,000 images, 70,000 images, and we took 60,000 of them for training and 10,000 of them for testing. So the value from 0.4347 dropped to 0.310 by epoch 14, and now it will raise up to 210 approximately, or it will be more loss. So now you can see predicted the number which is 7 in matplotlib. So in matplotlib we are viewing this so I'll just move this here. So in matplotlib we predict the image. You show the image here, and it'll show what is the actual prediction of the AI. So if I close this, the program will be stopped, and now I'll clear the terminal. So if you go here, you can see there's another new binary coded .pth file, which is the model. So in this model we will be having the trained model. So now if I run python GUI dot py, so what we will be using for the GUI is Pygame. So Pygame is like a 2D game developing library made by made for simple 2D games like platform games and all those. So here we'll be using it for digit classifier UI. We'll draw some digit like 4. So it's kind of not accurate. You can increase the accuracy by downloading a larger data set. So it sometimes shows this accuracy. So yeah, you can see predicted sometimes correctly and sometimes not. So you can see if we draw it here, it will show sometimes correctly. So yeah, this is how we can make a first deep learning model using Torch. You can also use TensorFlow and Keras for making this model, but I prefer using Torch. So yeah, later on we can do more on Torch and more in making AI models. Thank you.